Hey guys, it's Miss Butcher here. This video is 10.4, Probabilities of Disjoint and Overlapping Events. Got a summer picture here because this is my last video for you guys for this year. The next chapter will be Miss Irwin, and then we're all going to be gone for the summer. So I'll be sad. I know you'll miss me. Anyway. Alright, so we're going to start with the union or intersection of two events. It's called the compound event. So if we have event A, and it overlaps with event B. So we have some parts that, are in both. We call this the whole thing, we call the union of A and B. An example of this might be if A was all the smart kids at College Park, and B was all the cool kids at College Park, and then there's some of you, a lot of you, who are both. So I colored this part in the middle hot pink, and this part is called the intersection. Just the pink part, intersection of A and B. Should be obvious. Alright, so all of the points that are in this pink part, they're in both A and B. That's all of the kids that are smart and cool. And if we have events that don't have any overlap, we call those disjoint or mutually exclusive. So those are important vocabulary words. Disjoint or mutually exclusive. If they have no outcomes in common, there is no overlap. For example, if all of the A's were girls and all of the B's were the boys, we don't have anybody here who is both a girl and a boy at the same time, so we have no overlap. So when we're doing probability, if I have two events and I wanted the probability of something that was in both of the events, we have to consider the ones that are in the intersection of A and B, because if we just added all of the A's and all of the B's, well, some of those would be added in there twice. If I added up all the cool kids and then I added up all the smart kids, I would be double counting some of those people. Some of you guys are cool and smart, and I would be double counting you. So we have to consider the things that are in the intersection. So when we do our probability of compound events, if A and B are any two events, the probability of A or B, is the probability of A plus the probability of B, and then minus the probability of the ones that are in both, because we've counted them twice, so we have to subtract that to make up for the being counted twice. If they are disjoint events or mutually exclusive, then there is no P of A and B, and it's just PA plus PB. So really, if you just know this first one, and then you come across an event that's mutually exclusive, and so your PA and B would be 0, you can just get away with knowing the first equation and subtract 0, and it wouldn't make any difference. Alright, so in the spirit of summer, you have 6 chairs. Each chair is each a different color to choose from. If you are equally likely to pick any of them, what is the probability that you pick the yellow or the green one? Alright, so we'll let event A be choosing a yellow one. And we'll let event B be picking a green one. Now event A has only one outcome. There's only one yellow chair. Event B only has one outcome because there's only one green chair. They have no outcomes in common. There is no chair that is yellow and green. So our probability of A or B is going to be the probability of A plus the probability of B. I'm going to draw my picture here. And then minus the probability of both, right? So the probability of A is 1 out of 6 chairs. The probability of B is also 1 out of 6 chairs. The probability of both is none. There are no yellow and green chairs. 0. So the probability of A or B is 1/6 plus 1/6, which is 2/6 or 1/3. Alright, here's another one. A 6-sided die is rolled. What is the probability that the number rolled is odd or less than 3? So if we let event A be the odd numbers, there are 3 of those, right? And if we let B be the event that is less than 3, well, there are 2 of those. So the probability of A is 3 out of 6, because there's 6 sides to the die, right? Half of them are odd, plus the probability of B, which is 2 out of 6. Then we have to subtract the probability of A and B. So how many numbers are both A and B? How many numbers are odd that are also less than 3? Well, there's one of them. 1. 1 is the only odd number less than 3. So minus 1 out of 6. And when you put those together, 3/6 plus 2/6 minus 1/6, you get 4/6. And reduce that fraction, it's 2 out of 3, 2/3, or 66.67% chance. All right, next example. In a survey of 300 students, 150 of them like water parks or beaches. There are 97 students who like water parks and 83 who like beaches. So if you add 97 and 83 together, you will notice that that does not give you 150. So there is some overlap. All right, so what is the probability that a randomly selected student likes both? All right, so here's your equation, the one you need to memorize, the one you need to know. It's really simple, but, there's a couple of these on the test, so yeah. All right, so in a survey of 300 students, 150 like water parks or beaches. So that means that the probability of water parks or beaches, A and B being the water parks and beaches, was 150 out of 300 students. That equals, now the probability of A, the water parks, there was 97 out of those 300 students like water parks. And 83 out of 300 like beaches, and as I already said, 97 and 83 doesn't make 150. So we have to subtract the probability of A and B. How many kids like both? Well, that's what we're trying to figure out. So now it's just a simple algebra problem. Take 150 over 300, subtract 97 over 300, subtract 83 over 300, and we will get 30 over 300, which reduces down to 1/10, or 10%. We have a 10% probability that a randomly selected student will like both beaches and water parks. All right, here's another vocabulary word for you, the complement. The event A with a bar over the top of it is called the complement of A, and it consists of all outcomes not in A. So remember, complement in geometry, that was the opposite. So all the complement of A is just the opposite of A. And the probability of a complement is equal to 1 minus the probability of the original, right? Because if something could happen or not happen, then if you added those two probabilities up, you would get 1. So when you're finding the complement, you're just doing the opposite. For example, if I had a nice day outside planned and there was a 30% chance of rain, what would the chance be of no rain? And so you guys probably do this automatically in your head, but you'd say, well, 1 minus 0.3 is 0.7. So there's a 70% chance of no rain. Sounds much better saying 70% chance of no rain than 30% chance of rain, right? All right, my last example. When 2 6-sided die are rolled, there are 36 possible outcomes, right? Because there's 6 for each dice, and 6 times 6 is 36. So find the probability that the sum is not 4. All right, we first need to figure out how many combinations do add up to 4, because it'd be easier to do that than to figure out how many don't add up to 4, right? So those combinations would be rolling a 1 and a 3, or rolling a 2 and a 2, or rolling a 3 and then a 1. Those are the only ways we could get 4. So there are there are 3. The probability that the sum is 4 is 3 out of our 36, right? Now, the probability that the sum is not 4 would then just be the opposite of that. That would be 1 minus 3 over 30. That doesn't look like a 3. 3 over 36, which should be 33 out of 36. The other 33 possible combinations don't add up to 4. So 33 out of 36, which of course reduces to, I'm going to put it in green, 11 over 12 is the final answer. So we're just saying, instead of having to add them all up and figure out how many don't have sums of 4, it's easier to add up the ones that do and then subtract it from 1. So now find the probability that the sum is greater than or equal to 3. So first we need to figure out how can we get a sum that is greater than or equal to 3. Let's figure out the ones that are less than 3. And that's going to be 1 plus 1 is 2. 1 plus 2 is 3, so that won't work. 2 plus anything is going to be 3 or more, so only 1 plus 1. That's our only way. So the probability that the sum is less than 3 is 1 out of the 36. That means that our probability that the sum will be greater than or equal to 3 is the opposite of that. 1 minus 1 over 36, which is going to be 35 out of 36. And that is it. All right, I'm done. I hope you guys have a good next chapter with Miss Irwin and then a good summer, and come see me next year if you need any help. Bye.